Hey serverless friends, welcome to another Azure Functions University lesson. This time we're going to talk about blob storage, the blob binding and blob trigger, and in the TypeScript language. And I'm joined by Christian. Hello there.
Hi Mark, hi serverless friends.
How are you doing?
Fine, perfect. Nice
Yeah.
evening for having some serverless fun, right?
Exactly. The sun is out there, and unfortunately we are not there. But yeah, it's also nice to create this content for other people, right? So I'm very happy that you need created this content in TypeScript for this lesson. So thank you very much. Before we dive into the content, I want to quickly show the repository we have. You can go to it by this link, bit.ly az-func-uni. The repository contains a lot of lessons. Let me quickly show the lessons page here. So we already have quite a lot of lessons, most of them in .NET Core. Also now growing are the PowerShell lessons and now the TypeScript lessons. And in the next couple of months, I expect some more PowerShell lessons and some .NET Core lessons to arrive. Talking about logging, for instance, another one about durable functions. So there's more content coming really soon. But today we're talking about TypeScript and the blob bindings. So go ahead, Christian.
Yeah, then let's start with another one in the area of TypeScript. So we already had one session about HTTP triggered functions. So now we're moving on to another area, to the blob binding area. So yeah, jumping directly into the topic, navigating to the lesson. First of all, as mentioned, we will have a look at the things that we can do with blob bindings in Azure Functions, how we can use them, how we can create blobs, how we can read blobs, and how we can create functions that are triggered by blobs. Now, as usual, we have some prerequisites. Before we start, let's shortly walk through them. So in order to have a blob and in order to have a storage, and in order to develop locally, because that's, I think, what we really like to do, we use Azurite as storage emulator. So this is now really the go-to storage emulator. It's now supporting table storage, it's supporting blob storage, and it's supporting queue storage. And it's available for Windows, Linux, and of course macOS. So that's kind of the go-to solution now if you want to emulate Azure Storage. Then we need the Azure Storage Explorer in order to have a look into what's happening at the storage. And of course, in order to implement our function, we need a local folder. We need the Azure Function Core tools installed in order to use the Azure Function SLI and to have the Azure Worker, the VS Code extension, as you will see, in order to create functions, and any type of REST client, either Postman or the REST client extension for VS Code. If you want to dive deeper into the prerequisites, get all the links, there is a separate section on that one. So that's referenced here. Now, let's get the party started. So first of all, what is Blob? So Blob storage is basically a service that's hosted on Azure in order to store really large amounts of data and of unstructured data. So you store that, and you can then consequently access it via REST APIs using HTTP or HTTPS calls. Now, when I say large amounts, I really mean large amounts with respect to really hundreds of gigabytes of data in size. So that's really, I think I would say the S3 analogon in Azure.
Yeah.
Now, the storage account per se has a kind of structure. So what you have is on the topmost level is the storage account. So when you go to Azure, and let's shortly jump to the Azure portal. So we have a resource group, and within the resource group, we create a storage account. For this lesson, I have already prepared one because we need that at the very end. And within the storage account, we then can define containers, which are kind of a logical structuring within the storage account. And within one storage account, you can have multiple containers in there. And within the containers, you can then have the blobs. So you can have one or multiple blobs in a container. And in order to structure everything within the container, you can also have so-called folders within the container in order to have some substructure, which helps you to find things. Now, as mentioned before, we will mostly use the local storage explorer, storage emulator. Just for one part, we will use the one on the Azure portal.
Cool.
Now, first things first, you need to install Azurite if you do not have it yet, and install the Azure Storage Explorer. And then, in order to start Azurite, it makes sense to create a dedicated directory in order to store your data. You can also store it directly within your project, but so I'm not a friend of that. So I have a dedicated.
Sometimes I'm doing that in it, because I also like because Azurite is also available as VS Code extension, and if you use it that, well, then it's still optional. But by default, it will then just use the folder you're in. So that's a convenient way. But indeed, if you're planning to using it a lot, then it definitely makes sense to have just one space on your disk for all the storage. Yeah.
So that's kind of however you want to do it. And then you started via CLI. So I have the command here. Due to screen resolution, I have to scroll a bit. Now I will show that within the PowerShell. So basically, what I do is I start up Azurite, all the services that are there. So you can also start up single services via Azurite -blob or -q.
Mm-hmm.
And I tell Azurite explicitly where to store all the files. So that's the directory. And I also define the directory where to store all the log files. And what happens then, it creates does some scaffolding within the directory, puts all the necessary files in there, and then starts up a local service at the, I would say, default endpoints where all the other stuff that you have, like the Azure Storage Explorer, expects the endpoints of your local storage emulator. So that's basically it. And now let's start preparing stuff for the next steps. So let's move to the Storage Explorer. And within the Storage Explorer, you have one area, which is the local and attached one, where you have by default under storage accounts, so on this uppermost level, your emulator storage account. This is listening to the default ports. So if you started Azurite as I did, you have it.
Mm-hmm.
And then you have the different services that you can address. And we want to have a blob container. Now, we do not have one yet. So we create a new container, and we call that one players, because we put some player data in there. This now opens up your container, and you see, I have to juggle around a bit, the path up here. And we want to create now a folder as an additional structure within the container. So we say new folder, we pull that in for later used input binding, say OK. And now you see the path has changed.
Mm-hmm.
And what we do now is we can directly via drag and drop upload a file, and we take a JSON file, put it here, and then it takes a bit. And you will see here in the lower part of the log output, you will see that the file is transferred to the blob storage. You have the name in there, you have the timestamps when it was accessed, when it was last modified, the blob type. You have the content type here, which is extracted from the file extension. It's an application JSON. And that's basically it. And we have that now available within our little folder here. Now, what's contained within this JSON file is a little JSON with a little structure in it. I have an ID, I have a nickname, an email address, and a location with some nested structure, region, and country. Now, as you will see, when I started that lesson, I think there was WandaVision on Disney+, so it's kind of a little bit Avengers flavored, all the stuff that we will see later on.
I like that. I like that. Yeah.
Yeah. So that's now in there. So let's see what we can do next. We can, of course, also upload multiple files, but yeah, we don't need that for now. Now, let's start with our first binding, with the output binding. So what we want to achieve is we want to have a function that is an HTTP triggered function. So we want to call that function and use an output binding in order to transfer the information that is coming in via the HTTP call to the blob storage. So we want to store the information about a player in the container, in the player's container, in the out folder, and have everything there nice and ready. In order to create the function, as usual, I've created a directory. I started up Visual Studio Code within the directory. And now what we will do is we will create a function project within this directory. We will use TypeScript for this lesson. And we will use an HTTP triggered function. And we call that one store player with blob output. And for the access right, we take function. That doesn't matter for the local execution. Now, let me put that away. First of all, let's get rid of this red curly thingy. Let's do an npm install in order to install the Azure Functions npm package. And yeah, then let's first get rid of everything within that function because we will re-implement that in a second. And yeah, we have an HTTP trigger function. What we need now is we need this blob binding, right? So we go to the function.json, so to the configuration file. And what we want to do is we want to do a post request against the function and store some stuff within the blob storage. So first of all, we restrict the supported HTTP methods to post. And then we have the trigger binding that you probably know from the HTTP lesson, which is an HTTP trigger. We have the output binding towards HTTP. And now we add an additional output binding. And let me scroll a bit. So first of all, we want to have the type, and that's the blob type. So we want a binding of type blob. Then we want to give it a direction, and that's out. So push all the things out. We want to be able to address it within the function. That makes sense. So we give it a name. We call it player blob. And then every binding has some specifics with respect to the parameters. This binding now has the path as an additional parameter to the binding, which specifies the path to where the blob file should be posted. So which container should be used, and how should the file be named. Of course, we also have here, in our case, this folder in there. There are some additional parameters available, as you might have seen during the syntax highlighting. So we have the connection parameter, which allows you to define a dedicated connection at function level towards the blob storage. That's an optional parameter. If you do not define that, it will the worker runtime will kind of escalate and will take a look at your app settings, or if you're doing things locally, it will take a look at your local settings.json. The second one that is highlighted here is the data type, which kind of allows you to give the function runtime a hint what you're working with. Now, we're talking about TypeScript, so there are not as many things available as within the .NET runtime. So there is only binary, stream, and string. So yeah, not that super powerful.
Yeah, well, this was new to me. This is good to know about this. Yeah. Nice.
So yeah, that's basically all here. Now, one thing that I must not forget now is, of course, as we do not have the connection string here, I have to define the connection string somewhere. And I have to tell the function runtime to please use the development storage.
Yeah, exactly. Yeah. Yeah, so this will now use the emulated storage now. Yep.
Exactly. So it will now be directed to the emulated storage. And use that for this outbound binding. So as you can see here, you can also define a folder, and this folder does not need to exist. So it will be created by the binding magic.
Yeah, that's very nice. It makes it nicely dynamic.
Yeah. That makes it really usable. Yeah, that's it for the. Let's put that away. That's it for the configuration of the blob storage. So let's go to the implementation. So to the index.ts file. And what we want to do now is, if we get a request that contains a body, we will take the contents of the body and move it to the output binding. And if there is nothing, we will return an error message. So now making use of this super nice functionality within GitHub.
Oh, yeah.
If you have code blocks now, you get for free the copy button. That's
excellent.
Cool.
It's very, very useful for us.
Yeah. Absolutely. So we define a variable for the response status code. We define a variable for the response message because that's what we want to return to the HTTP output binding. And then we make a basic if-else branches. For the sake of this lesson, we will be, let's say, stretching the boundaries and not do production-ready stuff. So we will not check if the body is a JSON, it contains a valid JSON file with respect to the structure that we expect. We will just push it forward and keep our fingers crossed that everything is good.
Yeah.
I hope I did not change anything. No. German keyboard, good. Okay, now that's the error case. We return a status code 400. We say, hey, please provide some player data within the request. Otherwise, we cannot do anything.
Yeah.
Now, with respect to the happy case, so if there is data in there, it's really super easy to push that into the blob storage. You do not need any SDK setting up things with the SDK and knowing what to do. Well, it's always good if you know what to do, but you don't have to dive into the depth of blob storage. So what you do is you say now context bindings, and now you use the name that we have defined within the function.json. So we say player blob. We say, hey, dear Azure Function context, take the request body and push that into the player blob. And that's it. So that's all you have to do in order to transfer that to the output binding. Now, of course, we also want to hand back then a reasonable status code and a reasonable response message. And of course, we have to also fill this stuff into the HTTP output binding. So that's the same mechanism. So if you take a look here, so why is there a binding in between? That's because the blob binding is not baked into the Azure Functions core runtime. It's an additional binding. So here it's a bit different, something that you might stumble across. And we say bindings and then the name. Here we say context and we say res, which is exactly
that's also
this
the name
guy here
of the output binding there.
Yeah, and we hand over all the data that we need. So in this case, the custom status and the body. Now, for those of you who work with TypeScript, who work with JavaScript, they might see, okay, hey, body is type any. This should be a JSON, but it's also type any. So automatically, due to JavaScript, everything works, kind of. Okay.
That's not a lot of
code. Hopefully I did not forget anything. So I think this one, I don't know, is this better readable than the console down below?
I don't think there's a big difference, to be honest.
There's no big difference. So let's keep it here. So what we do now is an npm run start. So if you remember the last lesson, that's kind of the predefined scripts that we have here. The npm run start will then execute the pre-start, which we'll do on build. So the transpilation of the TypeScript sources to JavaScript, and then start up the function.
Yeah, let's do it.
Let's see if we made any errors. Looks good so far. Okay, looks very good. So we have now the endpoint. Everything looks fine. So what we will do now is we will make use of the REST extension of Weed's code. So we will send there a sample request. So basically we do a post to the endpoint, and I hope I have the right one. I have the content type that is a JSON file, and here I transfer some data for an additional player. I make use of some built-in functionality of the REST extension. So you have some nice functions in there, which, for example, lets you create some GUID for the ID out of the box. Let's fire the request. Let's see what happens. So the function gets executed. I get back my 201 created.
Okay.
And it tells me it's created. Now, don't believe an HTTP message. Let's see if really something happened.
It's under the 3 dots, I think, the refresh.
Nice resolution. So, okay, we have a new folder.
Yeah, that's good.
That looks good. We have an input. Let's open that one. Now, again, this takes a bit to transfer the data. And let's format it properly. Yeah.
There it is.
That looks good. That looks like the one that we created.
Excellent.
That's a quite decent start, right?
Yeah, exactly. Yeah. So basically, just one line of code to do the actual moving data to the output binding, and then some lines to make sure that you set the right status code, and that's it. So
and that's
it.
So and all the configuration is decoupled from the function. So that's great, especially for restarts.
Nice.
Okay. Now, I made a little mistake. Let's restart it. Now, the question is, what happens if I execute the exactly same request with the exactly same data. And according to the configuration, I have the same path. So what happens now? Let's find it out. No error message. Everything walked through nice and smoothly. Now let's take a look at the storage. So we have there a last modified somewhere around 623. So let's refresh it. It was just directly overwritten. So if you use the output binding with the same path, it's just overwriting what you put in there.
That's not going to be very useful, I think.
Can be a desired behavior.
If you always want the same file, then it's perfect. But indeed, if you want to add multiple records now, then it's going to be a bit
then
annoying.
You have a problem. So let's see how we can improve that. So there is one concept within the bindings that are the so-called binding expressions, which are built-in functionality within the binding framework, I would say, that allow you to make the handling of the declarative stuff that you define there a bit more dynamic. So, for example, in order to not overwrite everything every time, we can attach a binding expression that is called random GUID, which tells the binding functionality, hey, please create me a random GUID and put that on. There are several binding expressions. I think there is also one for date, so you can also attach a timestamp there. In order to make it a bit more flexible and in order not to overwrite things.
Sounds useful. Yeah.
So now this is also a cool thing. If you just change the function.json, of course, you do not need to recompile everything. So you just have a hot reload. And you can now execute the request again. And that's what we do. So we have now one file in there, plain text. We created now a second one, which should now use the binding expression. So let's refresh. And
there it is.
We have here a stored input where there is this very well to remember GUID in there. And if we do it now, if we play the game now again and say, okay, let's do it again. We will have another one. And it's a different GUID. It's the same file, but you can now really store multiple files in there.
Exactly. Yeah. Cool.
However, if you run it now several times with the same data input, you just get new input in there.
It's still a bit confusing, right?
Yeah, especially with a GUID that you do not have under control.
Yeah, exactly. Yeah, because the GUID is created in this case by the runtime, and it's not not related to the input whatsoever. Yeah.
Exactly. So the question is now, can we do even better, making use of those binding expression syntax? And yes, we can, because the binding expression syntax also has one very nice feature. It allows you to transfer the data from the incoming request, from the incoming HTTP request, to the binding without you having to do anything except for defining it.
That sounds magical.
So yeah, that's true magic happening behind the scenes. What we do now is we take the structure that we know and that hopefully is delivered always in the right way. In order to transfer that to the binding, and I will copy that one here. Yeah. So if you let's shortly open up the file again. So we have on the top level ID, we have nickname, and we have this nested structure where we have location and then region and country. And that's exactly what we take. We take the ID, we take the nickname. So this time the ID is provided by us, so we know how to address the file afterwards.
Yeah.
And we can even navigate within the JSON file.
Wow.
So even if you have nested structures, you can use that.
This is very nice.
Really useful.
Yeah.
Now this time, in order to make it visible what we do, and not to have any well, let's say GUID magic underneath, we will shortly change the response message and take the ID from where we get in.
Right. Yeah.
So that's the only thing that we change. All the rest remains the same. So let's get rid of that.
Yeah. So this is just to confirm quickly that the new ID is being used in the output.
Exactly.
Right.
Okay. So now we have restarted everything. Now let's take another famous member of the Avengers in order to put it in there. Now we again make use of this functionality of the extension to create the GUID, and we send the post request. Now, when we do so, this time we see, okay, we have now this GUID thingy coming up.
Yeah.
So A27, that should be sufficient. And now let's refresh. And here we go.
Oh, wow. Yeah.
So this works now really out of the box. It really works very well. And this now we can really, if we now, let's do this one shortly.
The first one again.
Yeah. Now we can really distinguish everything. So
this is pretty cool.
We have the GUID that we provide. We have the name. That's really, really useful now.
Yeah, this is very nice, these expressions. Yeah.
So, yeah, that's kind of it for the input binding. Now, if you are using .NET, or if you go to the documentation and you see what's possible in .NET, you will stumble across something that's doable within .NET Core 3.1 and within the upcoming .NET 6 embedded runtime, or I don't know how it's called. So not the isolated worker, but the one that
in process. Yeah. Okay.
Yeah, the in process. Yeah, that's the one. The in process .NET 6 runtime, which gives you even more flexibility. Now, what you have seen here is now you can do that in a declarative way, but you have to do it at design time. You can bring in some flexibility, but that's absolutely limited.
Yeah, it's not that at runtime you can change lots of things. Yeah,
exactly. Yeah. Within .NET, you can do that at runtime, which is an imperative binding. So you can do that really within the code, or dynamic binding, which makes more sense. Yeah. But that's not available for non.NET languages. So if you come across requirements where the binding simply is not sufficient, you have to go to the SDK. And as a tip, don't be religious about that discussion. If the binding does not work, if it's not sufficient for your requirements, use the SDK. Don't try to bend the possibilities that you have with all the flexibility options, just to make use of the output binding for the sake of the binding. So.
Yeah, exactly. Yeah, because the binding is just another wrapper on the SDK anyway, and when it's easy to use, then use the binding. But when it's not easy to use, well, I have to just fall back to the SDK anyway. Yeah, I think
go for the SDK. Yeah,
good advice. Yeah.
So that's something, because I had several discussions on that, and I'm sure you too.
Yeah, indeed. Yeah, don't go in reinventing the wheel and those kind of things. That's a waste of your time, probably.
Yeah, definitely.
All right.
Okay, then let's move forward and go down in the other direction. Let's do an input binding. Let's say we want to, when the function is triggered, read something out of the blob storage and hand it back to the caller, and have the same convenience as we had it for the output binding. So for that, we create another function. Again, we will use an HTTP trigger function, and we call it get player from blob. Yep. Function is fine. And of course, I should stop my runtime.
Oh.
That's something that it does really not like. Okay, doke. So first things first, clean up the code because we will start from a clean plate. We do the implementation of the code. Let's first go to the configuration again. So this time we want to read, so we only want to support a GET request. So we remove the post. And now, in contrast to before, we again want to have a blob type of binding. But this time, we want to have it inwards.
Right.
Again, we have to give it a name in order to be able to address it. How did I call it? Player blob in. And of course, I also need the path. And this time, we will use the thing that we created approximately 20 minutes ago. So we use the players container with the in folder, and within there our player file, which is formatted like this, right? So we have player minus number.json.
Right.
Okay.
Yeah. And
cool.
The one refers to the ID of the that's inside the JSON file, right?
Exactly. So now there is one thing that we have to add, or that we should add. We want to get the ID from the caller. So the caller should tell us which player do you want, and we give the player back. We can do that, so we do not have to keep our fingers crossed and hope that it comes in with a query parameter. But we can use a so-called routing definition within the function configuration, where you can define basically any route. So you can override the default route. This time we just say, hey, this is the route that we support, get player from blob, which is the default route in this case. And we expect an ID as part of the path of the route that you hand in to us. If you do not do that, you might not be that lucky in calling our function. Yeah, that's kind of an addition. This is something that we did not cover within the HTTP session, so you learned also now something about the HTTP binding.
Excellent.
Let's see if I have forgotten something. Yeah, of course, the let's say the binding expression or all the concepts around the blob binding are the same for the input binding as are for the output binding. So the structure is the same. The binding expressions are the same. There is no difference there.
Right. Okay.
So if you understand the concepts, that's always the most important part, because then you can really use that everywhere. Okay. Now, this time we get in the ID. So we want to read out the blob and hand that back to the call. And if we get an ID that might not exist within the storage, we have to respond to that one. And so we will one time give back a JSON file and one time give back a string file. So we also need to specify this within response header. So that's why we have this time 3 parameters: status code, the response message, and the header.
Okay.
Now, as usual, we have our if-else statement in there in order to distinguish the two cases. If we have this player blob in, transferred to us via the input binding. You see exactly the same way how to do it. We have the context, we have the bindings, we have the name. If that exists, we can give that back. If that does not exist, well, bad luck for the caller. And giving that back is straightforward. So as before, we hand back the response code. Now we specify a response header, which is content type application JSON, in order to have the right handling. And the response message. That's it. And of course, we have also to tackle the unhappy path. So if we did not find anything, so if the input binding did not do anything, we cannot return anything.
Exactly. Didn't find any matching blob, so a 404 makes sense because it's a not found. Makes sense. Cool.
So as before, bear with me tricking around. Banding TypeScript to JavaScript. So usually you would, of course, do a bit more type-specific stuff because otherwise TypeScript makes no sense. But for the sake of Azure Functions blob binding focus, we will leave that out. And then we have to return everything. As you can see now, we also transfer this header to the output binding on the HTTP side. And that's it. So we have our input binding. We get that into our function via the context object. We return it if there is something. We do not return it if there is nothing.
Clear.
So
so again, it's essentially only just one line to get the data in. It's nice.
It's exactly one line really to read the things. That's really comes in handy, for example, not for blob exactly, but if you want to read configurations that you want to use. That's something that's really super useful. As you can see now, we have also exposed the get endpoint successfully.
And we see the ID and the route they're mentioned as well.
So we have that one here, and as you can see, that's not an optional parameter; it's an obligatory parameter. And now the request is a little bit easier. So we take that route, we transfer one, and let's see what happens. Let's put that one away. Here we go. Peter Quill, the Starlord, is returned. Now, let's look. What happens if we take a 2?
Right, exactly.
Do we have a problem? Will the function runtime explode? No, it does not.
Not found, exactly.
So it's the not found. That's exactly what we defined. Now let's really stretch it. What happens if we took that away? Because we said ID is a non-optional parameter.
Right.
That's catched by the function runtime. So again, also not found because the route is not there.
But no additional information. All right.
So okay, that looks quite
nice.
Good, right?
Exactly.
Now, before I prepared that session, I of course took a look at the .NET session. I wouldn't say I copy-pasted it, but I took a look. I got some inspiration from there. And within .NET, you have the option now to, due to some more functionality that's in there, to enable the complete list of blobs that you have within your storage, also making use of bindings. Now this is where all the non.NET languages fall short of. So that's not possible. This for that you really have to make use of the SDK. And in order to give you a bit of a feeling how this looks like, then I have added that. So I want now to add the functionality that if there is a request that has no ID in it, I simply return the complete list of blobs that are stored within the path specified, within the container, exactly. So Yeah, first things first, we have to make sure that this is allowed and not prohibited by the function runtime. So we say now in the route expression, hey, the ID is optional. So if no ID is provided, please route the request to the function. But now we have to make sure that this is handled correctly.
Yeah.
Now, in order to get things going, we of course need the dependency installed. So we use the Azure Storage Blob. Now, usually I just take the latest one. During preparing the session, 12.6 has a bug in there.
Yeah.
Which should not happen during this recording. So I pinned it to 12.5.0, which works.
Yeah, exactly. So if you're watching this much later, there might be a newer version which is bug-free again. But for now, then keep it to this one. Yeah.
So if you take the default one with the little dash on top of it, as described here, if you get a strange error, it might be due to to this dependency. So let's then install the dependency, download the internet.
Whenever you find something strange in these things, I would always recommend to go to find the appropriate GitHub repository and then check the issues there, because it's very rare that you're the first one experiencing this issue. So I always advise, find the GitHub repo and check the issues, because it's very likely that someone else has found this already.
Exactly. It might not be solved, but at least you...
Yeah, at least you know that's an existing issue, and you're not the only one who's crying in the corner.
That's already good feeling. So usually there is also then a workaround provided.
Exactly. Yeah.
And for the implementation, of course, we now have to import this dependency to our function. And basically, the logic that we have should remain the same. So there is no difference if an ID is provided, but we have to check that, right? So we have to take that in, and we have to bring in the other case where we really want to read out complete storage. Now this is quite some code. So let's see if I have all the brackets right. Looks good. Okay. So let's shortly walk through it.
Yeah, what is it?
And let's skip the first line. I will come to that in a second. So we have now to specify the container name, which is players, because we have to specify that. And what we will do now, or what we want to aim at, is we want to get the file names and push that back as a string array. So we define this as a new array of type string. And then we have to do the kind of SDK dance that you usually have to do. First of all, you have to define the blob service client from the connection string, so from the string to your storage. And then you have to get the container client for the container that you want to have. Of course, you can do that within one line of code, but for the sake of readability, I put that in 2 lines.
Yeah, that's
and then you have several options on the client, and what I use is I list the blobs flat, and within this method I have some parameters that I can use. For example, I can specify a prefix. So this then corresponds to the folder that we have defined, because the folder is just a logical grouping. It's not a physical grouping like a container.
Yeah, it's more part of the file name than it's part of anything else. Yeah, right.
Exactly. And what we do is we have a for loop across that, looping over this asynchronous call, then fetching the blob and putting the blob name into an entry and pushing the entry into the array until there are no more entries. And what we do then is we take the response and hand it back.
Yep.
Rest is the same. So this is basically it. Now, I skipped this line. This is the connection string.
Yeah.
So I now need to specify, or I need to tell my blob service, hey, you have to go to that connection. Now I can use, of course, environment parameters. I can use directly the one that's available within the it's here within the storage account. So if you take a look either in the portal or within your storage explorer, you have all your connection strings here. So I take this one. Don't ever do that at home. Because you will then commit.
Yeah, we don't
probably
want to hard code its connection strings in the code. No.
Yep, that's one thing. And if you do a commit, guess what's on GitHub? Connection string to your database.
Everyone can connect to your data.
That's so usually take an setting within the local settings.json and then use that in here. As you can see, now this is really uncritical. It's the dev storage. So this is only your local storage that's running there. And with that, we are good to go. I have this also explicitly as a tip here. So don't do that. Use the app settings, and even if you use the app settings, don't put the keys in there, but use Azure Key Vault, managed identities whatsoever in order to get rid of this sensitive information from your configuration.
Yeah, good point.
And it also helps for if there is a key rotation or something like that, you do not rely on that. I think that should be it, right? So let's try it out. Let's see if I made any errors. Now you might ask yourself when you see the .NET sessions, they often use the F5 key in order to start the debugging. You can do that also for TypeScript. However, there is sometimes there is a little hiccup. So it does start the Azure Function runtime, but then when trying to attach the debugger, it runs into an error.
Oh, okay.
There's absolutely no error within your code. There is no error within your configuration. So if you run into something like that, just do an npm run start, check if everything is working fine, and then try it again with F5. Then it usually works. So it's also, I did not find any scheme why this happens. Sometimes it happens.
Good.
Okay, so we seem to be good to go. So let's see if we broke something.
Right, this is more like a regression test. Yeah, so with ID still works, right?
Yep. Yeah. So with ID it gets back. With a wrong ID,
right? Yeah.
It finds nothing. So the uppercase, we did not mess up something there.
Yeah.
And now, if we just put that away, that was a 404. Okay.
Yeah.
Now we get a 200. We get, well, this one entry. That's lame. That's cool. So let's go to the out path.
Oh, exactly. Yeah, right. Because there was just one file in the folder, but we know that there are multiple in the out folder. So let's have a look at that one.
Not that was not impressive, right? So.
Well, it did list all the files in there.
At least there was an error, yeah. So the worker process started, the host log, here we go. But sent, and now we have more.
Now we have a list.
So now we have all the nice things with GUID, without GUID, with all the nice stuff.
Yeah, very nice.
Okay, so yeah, we're already quite far now. So we have an output binding, we have an input binding.
Yeah.
What remains? Trigger. This is now where we use the storage within the Azure portal or within the Azure hosted environment.
Mm-hmm.
So here is described what you have to do. So it's really straightforward. Create a storage account. Take the basically cheapest one that you get. So no replication, no high availability whatsoever.
Yeah.
At least for that session. And I have already done that. So as we have seen before, I have this storage here.
Mm-hmm.
I have here my containers. I have this container called sample work items. So that's here, but that's empty.
Right. Yeah.
I have also connected my storage explorer to that account. So as you can see here, I have that one here, and I have my blob container here.
Right.
So everything is set from that side.
Mm-hmm. Mm-hmm.
Now, let's create a function that listens to exactly this container and gets triggered if there is an upload, if there is a change. So what we do now is we create an Azure Blob storage trigger.
Right, yeah.
We call that one, how do we call it? Hello World Blob trigger. Now here we create a new local app setting for the connection to the storage.
Mm-hmm.
And we use the first one, which was recently used. And we use this blob TS thingy that you have seen before. So that's exactly, where do I see it? Here, the Azure Functions University blob TS.
Yeah, because you are signed in with your Azure account, it knows where to, what are your available resources. So that's why it's possible that everything is listed here. Yeah.
So if you do that the first time, you get asked for your credentials in order to log into the Azure portal. This will direct you to the to your browser, and then everything is working.
Yep.
Now you can even do that from the function tooling directly.
Mm-hmm.
For me, that does not work always. So I created that before. Yeah, maybe just unlucky.
Okay, good to know. Yeah.
But give it a try and see what happens. Now, depending on if you created that now already in the setup as I have done it, there might be some question on what to use for debugging. Then if the question comes up, select the use local emulator, and then you're good to go.
All right.
Now, make sure that nothing fancy happened within the configuration as a next step. So we still are attached to the development storage. And we have now, as you can see, an additional entry here.
Right.
This is now exactly the connection string towards our blob storage within Azure.
Mm-hmm.
So if you take a look at the structure, it's similar to the one that we copied for our local storage. You have the endpoints, the account keys, and so on. That's for the global configuration. Now let's take a look at the configuration on the level of the function per se.
Mm-hmm.
So now we have just one binding in there because we have no HTTP trigger. We get triggered when the blob arrives within the storage.
Yeah.
I have a name, which is my blob. You can change that if you want. You have the type, which is now blob trigger. Mm-hmm. Of course, this is an input binding, as the trigger is a special case of input bindings. We have the path that we have defined. So we listen to the container sample work items, and we make use of the name of the file. Mm-hmm. And here now, the connection string comes into play. So it will not take the default storage string, but it will take the dedicated connection string, which is defined within local settings.json.
Yeah.
And so conceptually, exactly the same as the in output binding. Mm-hmm. Quite straightforward. Now let's take a look at the code we will leave the code completely untouched. What it will do is when there is a blob coming in, and you can see that here is an additional parameter within the function. We simply tell within the console, hey, there is a blob that came in. It has a name, and the blob size, which is an attribute of my blob, is this and that in bytes.
Right, yeah.
So that's all. And with that, I would say, let's go.
Ooh, exciting. All right.
So runtime is getting up. Okay, so we have our well-known companions of the previous exercises. And now we have one additional function that is starting up, which is the blob trigger. That looks good. So now what we want to do is,
now we need to add a file, right? Yeah.
Put a file in there. And now this is really something when preparing the session. Resolution is hell for the recording. So let's take a close look.
You want everything in screen, right?
I want everything in screen because it's fast. So it's really fast. What we do now is we upload the JSON file to the blob container within Azure. And we have our function sitting locally
right.
here in Bavaria, Germany, waiting for a file to upload. So hopefully this...
Yeah, transferring, it is already triggered.
It took the Storage Explorer longer to refresh the UI than the function to get triggered.
Yeah, and we see blob trigger function processed.
So
wow.
It's processed.
Yeah.
It processed the blob. So we have a name, player1.json. That's right.
Yeah.
And it's 170. Well. Yeah, probably that's right.
Explorer. Right. Yeah, exactly. Yeah.
Let's see.
I
would guess that's right. Yeah. So that's really super fast. So I mean, it's the blob storage is really pushed to the limits with 174 bytes, but it's really super fast. Yeah. So that's all the magic. So now you can use functions with blobs. You can write to blobs, you can read from blobs, and you can react if there is any change within the storage account if a blob file gets uploaded.
Very nice. Super versatile.
That's all for the session. Of course, we have a homework. Yep. So as usual, make your hands dirty with that stuff. It's fun. You can do everything, basically everything locally. So now picking up the HTTP lesson where you had designed an API in order to return your CV as a JSON file. Now let's make that a bit more sophisticated and don't put the JSON file hard-coded into your function. But now let's use blob binding in order to, let's say, upload a CV, or in order to fetch a CV, or in order to react onto a change within the CV. What we have done is basically the input binding within the assignment. So the scenario is you have an HTTP triggered function, you have your CV within your blob storage as a JSON file. Somebody uses your API, and you return your CV as JSON read from the blob storage. And yeah, that's all the magic. If you are doing that, we are happy to hear your progress, happy to hear if everything works. So share your progress. Share what you're doing on LinkedIn or Twitter using this little hashtag here. Mention us. We're both on Twitter. We're both on LinkedIn. We love to see what you're doing.
Yeah, definitely keep in touch about this. Yeah, we love that. Yeah, and also if you like this video, please give it a thumbs up. Please subscribe to this channel. And also if you like the content on the GitHub repo, please give it a star. That really helps us to get more visibility to this project. So any help is welcome there. And also if you want to contribute to writing a lesson and co-hosting like Christian is doing right now, please feel free to contact us about that as well. You can have a look indeed at the issues backlog. There are a lot of ideas there. You can create a new content request. If you skimmed through the list and there's nothing on there that you want to work on, but you have a new idea, feel free to add a new issue there, and then we can talk about it. Yeah, and also thanks to Christian, we now have really nicely issue templates as well. That works as a breeze. Yeah, so Christian, thanks a lot for this lesson. Even as a .NET developer, I'm learning more TypeScript now, and that's really valuable for me. And some things are really like super easy with TypeScript. So there's definitely pros and cons both ways. So it's nice to be able to learn a new language as well.
Absolutely.
Thanks everyone. Definitely like to see you at the next stream that we do, hopefully within a couple of weeks, because there will be more PowerShell lessons and also a .NET Core lesson. Or maybe I'll see you at the Azure Serverless Conference. That's also later this month. So until next lesson. Bye-bye.
Bye.